Let's take different model questions related to Gauss divergence theorem. So we'll have here two models, that is by evaluating the given integral, and second one is verify the Gauss divergence theorem. So evaluation is so simple, just you find about the volume integral. The second one is a verification, that means you have to find the surface integral and also volume integral. Now the first one is related to evaluate. By transforming into triple integral, evaluate double integral x cube dy dz plus x square y dz dx plus x square z dx dy, where S is the closed surface consisting of the cylinder x square plus y square is equal to a square, and the circular disc z is equal to 0, z is equal to b. Now in this, if you observe this integral, this is a double integral, that means this is the surface integral, and this expression is like our second formula, Cartesian formula. So this is like f1 dy dz plus f2 dz dx plus f3 dx dy. So we are comparing with that formula, we'll have like f1, f2, f3. Now to find the volume integral, so you know about what is Gauss divergence theorem. Integral over S f1 dy dz plus f2 dz dx plus f3 dx dy is equal to volume integral dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z into dx dy dz. So this is the formula. So if you find this volume integral, you will get the answer. So for this, you need to find first what is dou f1 by dou x plus dou f2 by dou y and dou f3 by dou z. So for that we have from the data f1, f2, f3. So in that, dou f1 by dou x is equal to 3x square. So here that f1 is doing partial differentiation with respect to x. So wherever the function with respect to x, that will be partially derivated. The remaining treat as constants. So here only the x term exists, so you can differentiate with this by x. So x cube derivative is 3x square. Next, dou f2 by dou y. So here the differentiable function is y. So this one is y. So you have to differentiate with this y, that becomes as 1, and x square is constant here. So x square into 1. Next, f3 x square z. So in that, dou f3 by dou z is equal to x square is a constant, so that is before that, and with the z, what is the derivative? 1. Now del dot f bar is equal to, that is also written as div f bar. So what is the form, that one? Dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So whatever we find in the previous, that you substitute there, you will get 5x square. Now you need to find the limits of this volume integral. For that, what the data we have, z is equal to 0 and z is equal to b. So z limits are given. Next, cylinder x square plus y square is equal to a square. So according to these two, we have to write the limits for x and y. So here given limits for z is 0 to b. So from the cylinder, we have x square plus y square is equal to a square. For that, y square is equal to x square, mean a square minus x square, and y is equal to plus or minus root of a square minus x square. So minus root of a square minus x square is the lower limit, plus root of a square minus x square is the upper limit. So we have find out this y limits. So then what about the x limits? Here x limits will be from the radius. So what we have here from the cylinder, x square plus y square is equal to a square. So a square here is the radius. So if you take the radius of this one, so what is the lower and upper limits? That is plus or minus a. So x limits are from minus a to a. So we substitute all these limits in the volume integral. So volume integral with the x limits minus a to a and y limits minus under root a square minus x square to under root a square minus x square, and here z limits 0 to b, and whatever we have the expression 5x square dx dy dz. So 5 is a constant, so we can write outside of the integral. And the next, the last integral that is related to z, you have to differentiate with respect to z. Here there is no z term, so x square treat as constant, so x square will be the same, and dz, integral dz is z. So z limits we have as 0 to b. So we have substituted that 0 to b. In that we'll get x square into b dx dy. Now here we have integral minus under root a square minus x square to under root a square minus x square. So this is you are converting to integral 0 to under root a square minus x square into x square b dx dy. How we can convert this one? Whenever the given function is an even function, you can have the integral like 2 integral 0 to under root a square minus x square. So here x square, so if you take x is even or odd, you will get even only. Why? Because that x is with the square. So have you got the point? Here we are converting this limits in a simple way, that f of x, that means x square is an even function, so we can write the integral as 2 integral 0 to under root a square minus x square. Next, like the same, this bx square will be the constant when you are differentiating, when you are integrating with y. That is here x square dx into, with respect to y you are integrating, you will get y from 0 to under root a square minus x square. So again, like the same style, you have to apply 2 integral 0 to a x square under root a square minus x square dx. So you have got this expression, and for this simplification there is no direct formula. That's why we are making substitution method. Here we are substituting x as a sin theta. Why? Because the expression is with a square minus x square dx. If it is a square plus x square, you have to take x is equal to a cos theta. It is minus a square minus x square, you are taking x is equal to a sin theta. So differentiating with this, dx is equal to a cos theta d theta. So whenever you are changing this x in terms of sine and cos, you have to replace the limits also with the theta limits. So here the limits are from x is equal to 0 to a. So you are converting that x is equal to 0 to a limits with the theta is equal to 0 to theta is equal to pi by 2. So changing these limits and substituting in this expression, you will have the, so what you have, that expression 20b is equal to integral 0 to pi by 2 a square sin square theta. That means you have here, what do you have in the previous step? X square. So x is equal to a sin theta, so a square sin square theta, and here root of a square minus a square sin square theta you will get into, this is a cos theta d theta. Now coming for this, So 20b integral 0 to pi by 2 a square sin square theta. So here we are taking out a square common, and that is under root. So it becomes a. Here 1 minus sin square theta is equal to cos square theta, that is under root, that becomes cos theta, and the remaining as the same a cos theta d theta. Now here we have a square, here a, here a. So how many total is a power 4. So I have written outside of the integral 20 a power 4 b integral 0 to pi by 2 sin square theta cos square theta d theta. So for this, if I multiply with 2 square, then you will get sin 2 theta. That means sin square 2 theta. So here what I am doing, you are multiplying with 2 square, and that 2 square I have taken from this 20. So 20 I can write as 5 into 4, and that 4 I have written here in terms of squares, that is 2. 2 sin theta cos theta whole square d theta. So this becomes as sin 2 theta whole square. So that can be written as sin square 2 theta d theta. Actually we have the formula for sin square a as 1 minus cos 2a by 2. So in the place of a, I have here 2 theta. So I can write 1 minus cos of 2 into 2 theta by 2. So for this you can simply integrate. So here by 2 is a constant, so I have written outside, and for this 1 d theta you have as theta minus this cos 4 theta, we have integral cos 4 theta as sin 4 theta by 4, and the limits we have as 0 to pi by 2. So I have substituted and got this finally 5 by 4 pi a power 4 b. So this is the evaluate question. Just we have completed the RHS solution. Now we are checking for the second model question, that is verifying the divergence theorem.